In this video, we'll talk about how to find the equation of an ellipse given the foci and the vertices. So the equation of an ellipse is written in the following form: x minus h squared over a squared plus y minus k squared over b squared is equal to 1, where the a squared and the b squared could be interchangeable depending on which denominator is larger. So the a squared will always be the larger denominator. So let's work through an example. Let's say we're told that some ellipse has the vertices -4, 0, and 4, 0. And let's say the foci of this ellipse are located at -2, 0, and 2, 0. So if we create a quick sketch to kind of visualize this situation, that could be helpful. So the vertices are at 4, 0, and -4, 0. And the foci are 2, 0, 1, 2, and -2, 0, 1, 2. So we can see that this ellipse will be horizontal oriented, so it'll look something like this. So the first thing that we want to do is we want to find what is the center of this ellipse. Well, the center is located directly in between the two vertices. So we can see that that point would be the origin. It would be 0, 0. And if you can't just visualize that off the top of your head, one way to find it is just take the average of the x values. So the -4 and the 4. So we could say -4 plus 4 divided by 2. This is the average of the x values. So -4 plus 4 is 0. So we get 0 over 2, which is equal to 0. So the x coordinate of the center will be 0, and the y coordinate will be 0, since both vertices have y coordinates of 0. So our center, we'll write center. When we have this equation of an ellipse, the center is located at h, k, which we just found is 0, 0. So we know that h is equal to 0, and k is also equal to 0. So now we just need to find out what is a squared and what is b squared. Well, a is the distance between the center of the ellipse and the vertices. So a, we can see, is equal to 4. B is going to be the distance between the center and the covertices. So this is B, because the covertices are on these points of the ellipse. And we don't know what B is, but we do know that the following relationship exists. C squared is equal to A squared minus B squared, where C is the distance from the center to the foci. So we can see that this distance from the center of the ellipse to the foci is equal to 2. So plugging these numbers in, we can say 2 squared, or 4, is equal to A squared, so A is 4, so 4 squared is 16, minus B squared. So to solve for B squared, we can move the B squared to the left side, and we can subtract a 4, so we'll get B squared is equal to 16 minus 4 is 12. So now we have everything that we need to write this final equation of this ellipse. So we have x minus h we said is 0, squared, over a squared. A we said was 4, so 4 squared is 16, plus y minus k, we said k is also equal to 0, squared, over b squared. And we just found that b squared is equal to 12, is equal to 1. So we can simplify this a bit and just write it as x minus 0 squared, that's just x squared. So we'll write x squared over 16, plus y minus 0 squared, that's just y squared. So we'll write y squared over 12 is equal to 1. And that is our final answer. That is the equation of this ellipse. And we were able to find that using just the vertices and the foci.